Okay, hello everyone, my name is Yelaman, and this is Machine Learning Assignment 3 presentation. So shall we start? Today I'm going to talk about like general overview about model and the prediction results and the conclusion of the prediction. So shall we start? Basically first I would like to introduce the, the test, the data set. So it's called a K-MNIST. Kazushidi MNIST or cursive Harigana MNIST was introduced as an alternative to MNIST. It contains images with the first entries from the 10 main Japanese Harigana character groups. So you can see them here. So let's go here and go a little bit deeper for each picture. So each image is 28 pixels height and 28 pixels in width for a total of 784 pixels in total. Since it's only a grayscale, it's not RGB as usual pictures. It has only one, so we have 28 by 28 by 1. So basically it's 784 picture. And the images are stored in NumPy arrays. If you go to the GitHub like source of this data set, you will find that they are stored in NumPy arrays with 60,000 28 by 28 and 10,000 28 by 28 respectively. So it had like 10 test images, and first is like training images, and second is the test images. So the labels are also stored in two NumPy arrays, one for train and another for test also. So yeah, let's start. And basically, MNIST is the de facto hello world dataset of computer vision. So yeah, it was said by someone not famous. I don't know who is it, but it's basically just a hello world of computer vision. So let's start with overview. So for that exploration, I just want to see whether everything is as was described in the dataset on the GitHub page. And here, yeah, we can see that it is like train shape is 6,000 pictures, 28 by 28 pictures, and the test shape picture is like 10,000 pictures, and the train shape is just labels 60,000 and 10,000 labels like also. And here we have like indexes of the labels. So we have like 0 to 9, like 10 labels since it's in this data set. So let's go next. And distribution. Here we can see that the test data set is fairly distributed. 10% for each class, for each letter. So like it means 6,000 for each class. So it's like totally fairly distributed here. Next, let's plot some sample images. We just can select to ensure the pictures are here. We can see this is trained dataset images, just random pictures, just one sample, and another also sample of test dataset images. Here we can see this is what we are gonna work with. Okay, let's talk about model. Here we're gonna use a sequential model, which is like linear stack of layers, right? And first we're gonna initialize it and then add a layer by layer. First layer is conv2, which is convolutional 2D convolutional layer, which has a filter, like the number of filters, which is 32. The kernel size is 3 by 3, and with activation relu, in this case relu, and input 28 by 28 in our case. And then we have conv 2D with the following parameters: filter 32 3 by 3 with activation relu, max pooling with pool size 2 by 2, 2 and 2, and then we have dropout with rate 0.25, and we have max pooling. And here dropout is like consists in random setting a fraction rate of input units to 0 to each update during the training time, which help prevent overfitting. The parameter in this case we use 0.25, and then we again go to conv 2D, which filters 64 3 by 3 relu, max pooling, pool size 2 by 2, conv 2do we filtered 128 3 by 3 relu, and dropouts with rate 0.4. Then we have flatten and dense with 10 with activation of softmax. So this is the diagram of our model. Let's go further, and when we run it, we're gonna have like just a summary of the model. We're gonna have something like that in the our collab in our IDE in our notebook. And in our case, we use loss, which is cross entropy, optimizer ADAM, and metrics accuracy. We use such metrics, and we get something like that. During each like 10, I use 10 epochs. Also, you can be changed it, but since the CNN model is kind of complicated comparing to just regression model, for example, it trains for a long time, especially in my case where my like the cloud which is used in Colab is not really powerful. So it takes like much time. You can see how much it takes for, like, for example, for last epoch it takes like 168 seconds for whole training. And then here we get such output of this training model. So we have like training and validation accuracy. At the beginning, I divided the training and validation sets. Like I divided training set to training and validation set. The training set is like training and validation ratio is like 90 to 10. So 10% is validation set and training set is 90%. We have like the validation accuracy, training accuracy, and training and validation loss. Here we can observe these numbers. And if we go to the prediction part, in this prediction, we have checked on validation with validation set. On validation, we have like correct predicted classes 5,000, like 5,889, and incorrect predicted 111. So here we can see that the overall accuracy, we can say like around 0.98, like 98%. So you can see here observation of all the stuff like precision recall, F1 score support. Here we can get like make a function which can output only true, like only correct outputs and only incorrect outputs. So here this is correct, which green and red is incorrect. Also we did it. Also, of course, we need to do the prediction with test set. And on the test set, the numbers a little bit lower. However, yeah, it's a test set, never seen by the model. And here we can see like the 93% of accuracy. Basically, if I had bigger epochs, it would be better, like around maybe more. But since only 10 epochs used in this case, the accuracy a little bit lower. But however, overall accuracy is 93%. So yeah, here we can get the predictions, this one and this one, and also test prediction. So it's like was in the task sheet to have like 100 pictures, random pictures. So it's a sample of 100 pictures, and we have like, we can see like, for example, this is incorrect, right? But yeah, it just want overall 100 predictions and with 93% of accuracy. Yeah, thank you for listening. And this is my conclusion. So we have like amount of epochs 10, 98% of accuracy, accuracy of validation set, and 93% of test set. So yeah, thank you for listening. If you have any questions, you can ask on this email and send WhatsApp messages on this number.